We're working on chapter 15 this week, which is going to be lipids. And in this chapter, you're going to get a chance to review some of our old chapters. So just a heads up here. We will look at chapter 4, and some of the things you need to know from chapter 4 are intermolecular forces, or IMFs. Another major principle that we'll see here is that like dissolves like, and that was something that we worked on in chapter 4, and we also talked about in chapter 7 with things mixing. From there, we will also use material from chapter 8 and from chapter 13, and that will be looking at carboxylic acids and also esters. And so those were a couple things that we've seen for a while now, our carboxylic acids and our esters. Next, the other chapter we will tie into is chapter 11. We're going to see alkenes again, and we will be looking at some of those features of alkenes being cis or being trans. So we will be looking at those again. Also, big picture on our lipids. I want you to be able to think about our lipids in two different categories. Lipids that contain ester bonds and lipids that do not contain esters. And we will spend more of our time on these that contain the ester bonds. The types of lipids that we'll see that contain esters are our triglycerides, and then also phospholipids, which we see in cell membranes. And then the types of lipids that do not contain esters are going to be our vitamins and also steroids, which we will see a bit later on. So those are our two categories of lipids. The first thing we'll see on the next page is that all of these lipids are going to be relatively non-polar. So you want to review some of this old stuff and then keep this big picture in mind as we move into chapter 15. So on this first page here, we want to define what lipids are. I'm going to give you just a couple of key words here. So lipids are all going to be non-polar compounds. And this is different from what we saw like with the carbohydrates. We were really focused on what functional groups are there. But for lipids, you just want to focus on, hey, it's very non-polar. And if it's non-polar, we're expecting to see lots of carbons and hydrogens, right? So that goes back to sharing electrons well. There's not a positive or negative somewhere in this molecule. Because they're non-polar, like mixes with like, so we would also say in defining these lipids that they're soluble in non-polar solvents. And most of them are not going to dissolve in polar solvents. We'll see a couple exceptions to that, but our lipids are nonpolar compounds and they mix or dissolve well in nonpolar solvents. So as we work on our lipids, we want to take a look first at some of the building blocks of these lipids. And one of the key building blocks you see in some of our lipids is a fatty acid. So I'm going to just sketch one here for you. At one end, I have a carboxylic acid, and I wrote the carbon there. Now I kind of regret that. And then I have a really long tail coming after it. And we saw these at a glimpse back in, I think, chapter 13. So here at the front end, and I could have just drawn this as a dot as well, I have a carboxylic acid. And then I have this long carbon tail. Notice this long carbon tail doesn't have any double bonds in it. So I would say that this tail is all carbon-carbon single bonds, and that means that I would describe this fatty acid as a saturated fatty acid, Fa for fatty acid. In contrast, look over here at these tails. So here I also have carboxylic acids. That's where this acid comes from in the name, fatty acid. So they're all carboxylic acids. And then when I turn my eyes to these long tails, I see a functional group that wasn't there before. And in here, I see a bunch of alkenes, right? And are they cis or trans? Can you tell? So can you see that these are all cis double bonds? These would all be naturally occurring. And I have here unsaturated fatty acids. So all of these to the right are unsaturated because they have those double bonds, and all of them to the left are saturated, or the one to the left is saturated because it's all single bonds. We don't look at the carbonyl when we're talking about saturated or unsaturated. We're just going to go ahead and look at the carbon bonds there. So when I talk about these fatty acids, let's come back here for a moment. I would describe this as the polar head of my fatty acid. And because it's got these polar bonds and an OH in it even, we would describe this potentially, we'll get back to soap, as hydrophilic. Hydrophilic is just another way of saying that it loves water. And then down here, the rest of this molecule, we would say is the nonpolar tail. And another word for that we'll be using with our biomolecules is that it's hydrophobic. Hydrophobic would be how we would say that it fears water. So not a big fan of water. So in our fatty acids, we have these polar heads that are hydrophilic and nonpolar tails that are hydrophobic. Same thing happening here. Pink would be my polar heads. The tails are all hydrophobic. One more thing I want to point out to you here with these fatty acids is when I look at the tails, you see there's some numbers here. These are described as omega-3 and omega-6 fatty acids. You might have heard those in nutrition before. When we talk about carboxylic acids, this first carbon next to the functional group, so you can see it here, that's called the alpha carbon. And in the Greek alphabet, it starts at alpha and it ends in omega, which looks like a W here. So this is the alpha end of the acid, this is the omega end. If I count from the omega end in, and I count 1 carbon, 2 carbons, 3 carbons, I would say that this is an omega-3 fatty acid. Here, again, go to not the functional group end, but the other end, the omega end, 1, 2, 3. That's where that first double bond starts, so this is another omega-3 fatty acid. Check out down here, it takes a while longer to get to that first cis bond, right? 1, 2, 3, 4, 5, 6. So this would be called an omega-6 fatty acid. I'll leave a couple more there for you to be able to look at. In general, these omega-3s are known to fight inflammation, so those are very positive. Omega-6s show up in a lot of the same places as omega-3s, but more so in like your vegetable oils, and those, they're still learning, but they seem to maybe cause some inflammation. So not all omegas are created equal. These are definitely good for you, or great for you, and the others we're not quite sure. And that's the hard thing with a lot of nutrition is there's more question marks than things that we understand really, really well. But all of these with the cis double bonds would be found in plants, and so therefore we would find them in our vegetable oils. So that's a beginning of introduction to lipids and fatty acids. Next up, we'll take a look at soap here.